Hello, my name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the SAT. We have been solving math problems out of this book here, the official SAT study guide, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that I'm about to solve is the one that you will find on page number 399. Today is our lesson number 10. Please turn to page 399, the very first problem. It says, when a positive integer k is divided by 7, remainder is 6. Question simply is, what's the remainder when you divide k plus 2 by 7? Now, before we worry about the punchline, let's first talk about a couple of things. What does integer mean? When a positive integer, what does integer mean? Integer is just a fancy name, a fancy way of saying a whole number. You already know that. Before we do this thing, let me ask you this question. What is that number which when divided by 7 gives us a remainder of 3. Now this actually, strictly speaking, this is not a proper question because it sounds like there's only one answer. There are infinite number of answers here. What I should say is give me a number. Give me a number which when divided by 7 gives us a remainder of 3. Can you answer this question first? Can you give me a number which when divided by 7 gives you a remainder of 3? Now sometimes when kids are not paying attention, to an answer like this, I usually get to a question like this, I usually get an answer of 21. Because they figured if you divide 21 by 7, you get 3. Let's do it in the longhand here. 21 divided by 7 gives you 3. That, what you just saw there, this here, or this here, is not a remainder. Remainder is what is left over here. Here we have a remainder of 0. Why do we have a remainder of 0 when you divide 21 by 7? Because 21 goes evenly into 7. This is not a remainder. They confuse the concept of remainder with quotient. And if I did not spell it correctly, don't worry about it. Look up spell it yourself properly. I'm not going to waste time right now. It's called quotient. That is not. So can you think of a number which when I divide by 7 gives me a remainder of 3? How about 24? Well, if you divide 24 by 7 3 times, it gives you a remainder of 3. In this case, the remainder is same as quotient. How about 45? 45 divided by 7. How many 7s in 45s? Well, 7 5s are 35s, and one more 7 would make it 42. So that's 6. Now this has a remainder of 3. Can you think of another number? How about 17? 17 divided by 7 gives you a remainder of 3. But what I want you to think of is the smallest possible number. It's the simplest number that you can give me that will satisfy this condition. A number which when divided by 7 gives you a remainder of 3. When somebody asks you a question like this, the simplest and the easiest and the quickest way to figure out the answer is to take this number 7 and add to it a 3. But we know 7 can be divided by 7 evenly, obviously, because it's going to go one time and you want a remainder of 3. So what better way than to simply take that 7 and add 3 to it? This will ensure that we have a remainder of 3 because we forced there. We put the 3 there. So now 10 divided by 3 will give us remainder of 10 divided by 7 rather will give us the remainder of 3 because 10 is 3 more than 7. 7 goes into 7, so 3 more than 7, and that 3 will be remainder. This will give us a remainder of 3. 1 and 3 7. Let's do one more, shall we? Let's do one more. And you will understand where I'm going with this thing. Sometimes you have to be patient in order to learn where the teacher is going. Let's do one more. Can you give me a number? Give me a number which, when divided by 5, gives me a remainder of 4. Well, that's very easy. If you want a remainder of 4, a number which, when divided by 5, with a remainder of 4, well, that's very simple. Take your 5 and add the remainder to it. Because again, we know 5 goes into 5 one time. So if you were to add 4 to it, that will give us a remainder of 4. Just give me 1 second, I'll be right back. Here's another one. Can you give me a number? Give me a number which, when divided by 13, gives me a remainder of 5. Well, you get the idea. It's very simple. That will be 13 plus 5. Again, 13 divided by 13 is 1. 13 goes evenly into 13 obviously, and we want a remainder of 5. So what better way, instead of wasting your time and going out on a limb and looking for a number which satisfies this condition when you divide by 13 gives you 5, the simplest and the easiest way is to take the number, add the remainder to it, and that will ensure that you will have the remainder of 5. We're going to do the same exact thing here. We're going to plug in a number. We are going to plug in a number which satisfies this condition. When k is divided by 7, the remainder is 6. What would that number be? Well, that number would be 7 plus 6. Because 7 divided by 7, of course, is 1. It goes evenly into it. We want a remainder of 6. Well, what better way to make sure that we have a remainder of 6 than to simply add 6 to it? And that will give us a remainder of 6 because we just added 6 to it. That's it, 13. Let's plug in 13 for k. We're not going to solve this problem algebraically. We're going to plug in a number. And this is the smallest number that you can plug in. That's what I'm trying to make you understand. There are several values that will work here, but the smallest value that you can plug in here for k is 13. 7 plus however much remainder you want. 7 plus 6, 13. Now let's read the punchline. The punchline is, what is the remainder when k plus 2 is divided by 7? Well, all of a sudden this becomes a very simple question, very straightforward question. Rk is 13 here, so that goes here. Rk is 13. 13 plus 2 is 15. So if you were to divide 15 by 7, what's going to be the remainder? Obviously 1, because 2 sevens make 14 with the remainder of 1. This is your remainder there. That's it. That's our answer. The remainder is going to be 1. The answer is B. That's it. The key here is to plug in a number that works and keep your number as small as possible. The smaller the number, the less work you're going to do. Give me a number which, when divided by 103, gives me a remainder of 17. Well, that's very easy. That number, the smallest number would be, which when divided by 103, gives me a remainder of 17. That will be 120. 120 divided by 103 is going to give me a remainder of 17. Give me a number which when divided by 9 gives me a remainder of 5. Well, that will be 9 plus 5. 9 plus 5 divided by 9 will give me a remainder of 5 because I just forced it to be like that. 9 divided into 9. You get the idea. That's what it was. I will see you tomorrow. When we'll do problem number 12 at the bottom there. Alright? The problems are getting a little bit more difficult now. They are still medium questions. We are not into hard questions yet. But they're getting a little bit more tricky. So we'll take our time. That's the idea. I could very easily make 3, 4, 5 problems at once together. But I don't want to rush through it. We'll take our sweet time and we'll learn properly. Okay? I'll see you tomorrow. Bye now.